Okay. Good morning, children. Today we are starting with a new chapter, a very important chapter, that is chemical equilibrium. First of all, let me discuss a case of physical equilibrium. Then I will take up a case of chemical equilibrium. Suppose we have a container. And say this container is uh, is uh, is covered by a sort of belger, and it is, say, airtight, and say this is there is a pressure gauge. There is a pressure gauge by which we can measure the pressure of gas if it is inside. So a pressure gauge is fixed. Now suppose we are initially pressure inside will be very less. There is almost vacuum inside, so pressure will be very less inside. Okay. After that, what we do? We take some water. We take some water in this container. We take some water in the container, and then we see the reading of the pressure gauge. So what we will see after we take the water, after we put the belger with the pressure gauge, what will happen? We will see that pressure will gradually increase. Pressure will gradually increase, keep on increasing. But after some time, pressure will not change. Pressure will become constant. So how do we explain this thing? First of all, why is the pressure increasing? The pressure is increasing because there will be evaporation taking place. That is, H2O liquid will get changed to H2O gas. This process will take place, and this water vapor will exert pressure, and since this process will keep on increasing with time, so pressure of the water vapor will also increase. So the gradual rise in pressure is due to more and more water vapor accumulating here, and this vapor or this gas exerting pressure. That's why pressure is increasing. Now, after some time, what will also happen? There will be opposite process also taking place. Opposite process will also take place here. I mean, what opposite process will take place? H2O gas will change into H2O liquid. So this process will also take place. So what will happen is there will be two processes taking place here. One is H2O liquid to H2O gas, which is called evaporation, and another is H2O gas to H2O liquid, that is, you can say, condensation. And after some time, the rate of evaporation and the rate of condensation will be equal. rate of evaporation will be equal to rate of condensation. Rate of evaporation will be equal to rate of condensation, and when this thing happens, then you will see that pressure will become constant, pressure will become same. And when pressure becomes same, then we say that this system has attained equilibrium. So we can say at equilibrium, rate of evaporation is equal to rate of condensation. That happens at equilibrium. And this equilibrium process we express in this way: H2O liquid H2 liquid reversible H2O gas. So this is sign for equilibrium. So what is happening is that liquid changing to gas and gas changing to liquid, it is taking place at equal rate, and when this thing has attained, then it is called equilibrium. Equilibrium are of two types. One is physical equilibrium and chemical equilibrium. This is one case of physical equilibrium. So, what happens at equilibrium, is there are two processes taking place, and they are taking place at equal rate. This thing happens even in case of chemical equilibrium. Now I will give you an example of chemical equilibrium, and let me also tell you about a term called vapor pressure, which you already know. At equilibrium, when equilibrium has been attained, the pressure which these vapors exert, is called the vapor pressure of the liquid, that we have studied in states of matter chapter. Now I am explaining you give an example of the case of chemical equilibrium. So suppose we have a closed chamber where we have a container, and we have here calcium carbonate. Calcium carbonate is solid. Yes, and this is fitted with a U tube, and here we have mercury. In this U tube we have mercury. Mercury is liquid. So we have mercury in this U tube. So we have mercury here, we have calcium carbonate solid here, and the height of mercury in both the limbs will be equal. Okay, now we will slowly, gradually do the heating process. We'll heat this calcium carbonate. And you know what happens when calcium carbonate is heated? So calcium carbonate solid will break down into calcium oxide solid plus CO2 gas. This will happen. So carbon dioxide gas will form. Carbon dioxide will come this side. It will exert pressure. And what will happen is gradually this level will descend, and this one will ascend. This one will go down, this one will go up. So this thing you can see, notice. So as we are doing heating, this one will gradually come down, this one will gradually come up. So this one will happen. So you are heating, this thing is happening. Now how long will it happen? It will not happen continuously. What will happen is after some time, there won't be any further change. Suppose after some time, the level of mercury it becomes like this, and level here it becomes like this. Okay, level here becomes like this, and after that there won't be any change. So why there is no further change? Because a state of equilibrium has been reached. A state of equilibrium has been reached, and inside it there are two processes taking place. Initially this was the process taking place, but after some time there will be another process, a reverse process starting, and the reverse process is CaO solid plus CO2 gas after some time. This process also taking place, and we call this process as forward process. We say this process as backward process. So this is you can say a forward reaction, this is backward reaction. And since at equilibrium these two processes will take place at equal rate at equilibrium. So at equilibrium we can describe this process in this way: CaCO3 solid, equilibrium CaO solid plus CO2 gas. So this process at equilibrium is written like this, and as already said, there are CO3 arrow CaO plus CO2 forward process, and CO2 plus CaO combining to form CaCO3 is backward process. So these two forward and backward process at equilibrium takes place at equal rate, and that's why the level of mercury becomes stationary after some time or at equilibrium. Now one thing, this equilibrium, whether it is physical equilibrium or chemical equilibrium, it is dynamic in nature, because even if the level of mercury becomes same, even if the pressure of vapor pressure becomes constant, two opposite process keeps on happening even at equilibrium. Okay, it doesn't mean that at equilibrium the process has stopped. The process keeps on happening even at equilibrium. That's why we say the nature of the equilibrium to be a dynamic equilibrium. So in this video I had given you the concept of equilibrium, and in our next video, subsequent video, we will be starting, we'll do real starting of chemical equilibrium. Till then, bye bye and have a good day.